Hello, welcome to the Edgecam and Automation webinar. My name is Miguel Johan. I am the Market and Product Manager for Production Machining at Hexagon Manufacturing Intelligence. In the agenda for you today, we have a big list of Edgecam experts who are going to be talking about different subjects on the area of automation. It's going to take a little longer than the hour scheduled, so I hope this is not a problem for you. But we try to keep it very, very interesting, so let's dive right in. The agenda today is packed. We start with a quick introduction about the continuous process improvement and how we do that seamlessly in Edgecam. Then I have our first guest, Joe Sanders, talking about the intelligence in programming workflow, followed by Patrick Leutner from Germany, who talked to us about the CAM database of Edgecam. Mike O'Neill from the UK is going to talk about macros and best practice toolpaths, followed by our colleague David Curra talking about strategy manager. Right after him, Raf Goppold, again from Germany, is going to be talking about virtual machine automation and Code Wizard. Pierandrea Capelletto from Italy is going to be showing machining setup automation, and we bring it home with a very important customer success story with our American colleague Jim Jackson. Yeah, after that, we hope to have enough time for a summary and your questions and our answers. So what can I use automation for? What can I use the Edgecam tools to improve in my everyday life? So anyone that knows how to program CAM, knows how to use Edgecam, can progress from simple macro to complex automation projects using the Edgecam API, and they do that on the same development environment. You literally grow from very, very simple, and you can progress incrementally into that universe until reaching the point of complexity that you want. Yeah, you start with macros. We go into plugins, which use the same API, so you can be working on an open script, and that those functions can be called from a .NET plugin. And you can work with an extended API for functions that are not necessarily called from the application. They are not macro record and playback, literally having access to all of the application. Yeah, those tools would bring to us ability to work with basic things like feature patterns, you're just drawing, command automation, integration with Excel, bring intelligence and data into CAM. Family of parts, being able to basically repeat the process with different parameters and reach some level of part creation. Reading PMI, which are in files on the disk or extra information that you might have attached to your model. You start to be able to create new commands. You start to be able to group commands into a single dialog. You start to be able to create logging files about the job you're doing. You'll be able to validate the job you're doing. You can integrate with the web APIs and make them talk to Edgecam. And eventually reach hopefully fully automated CAM or as automated as you want, and reach a point where you can do anything with the application. To start showing this path into the universe of automation of Edgecam, I have the pleasure to introduce my great friend and colleague, Joe Sanders from America. Hello, Joe.
Hello, Miguel.
So good to have you here with us today. So the first item on our agenda today is to try and explain how do you start with Edgecam? How, after installation, how you start to see the benefits and build up into this automation universe of the application.
Yeah, great question, Miguel. I'm going to be showing how to do that, and I'm going to be using Edgecam largely out of the box, the way that it would work at a customer with a turnkeyed installation. So I have the post processors that drive my machine tools. I have a tool database that is my virtual tool crib and represents the cutting tools I have available. And other than that, it's largely just out-of-the-box Edgecam.
Good stuff. So Joe, can we start with one of my favorite Edgecam commands, which are the auto-determine environment, auto-align for milling, auto-align for turning commands. What is the intelligence behind those commands?
If I was to go and look back at our preferences, which drive the behind-the-scenes behavior of the software and tailor it to our environment, we can see that we have ability to auto-select the environment to align the part for turning or milling based on analyzing whether the part is more closely suited to turning or milling, and also to preload common datums. I want to show what happens if we do not select the alignment and load the part. So I'm going to dump that file and then go reload that same part. When we load this solid and go have a look at it, notice that now the part is a long way removed from our 0 point. This is in the same orientation that was done in the CAD system. So the CAD designer wants to set an origin at a convenient place for them, and we want them to do that. Auto alignment very quickly handled the part alignment to a convenient starting point for us. So we can see that's a big deal. Again, to illustrate that, I'm going to go back and into preferences, and I'll turn the alignment stuff back on. This is normally the way I want to drive the software. Let's also this time say that our datum position is at the mid volume of the part. Again, we'll dump the file and reopen the same solid. We see the part alignment puts the part in a convenient position. I can then from there further orient the part. So I want the part to sit this way. So we see the part orientation. Now, what would happen if we were to have a design change? When I reload this part and I load in a different file, Rev2, notice that when the part is reloaded, it reloads with the same orientation as the previous one. In fact, Edgecam is really intelligent about this. So if I bring in a stock shape that represents a casting or forging, that stock shape, if we turn off the rendering of the part and turn on the rendering of the stock, we can see that that stock shape is also correctly aligned to the part. Very intelligent auto alignment that can save us a ton of time. Let's look at how that works on a turn part. We don't want to forget about our turn users. They're a core consideration of Edgecam, and some excellent technology here that's very parallel to milling. Edgecam detects this part's better suited to turning. I can very quickly flip the part the other direction and notice that because my request is that datum's in the front of the part, that the datum orientation that I have selected is preserved. We can also look at C-axis orientation. So I can select one of these holes, and without knowing the angle of that, I can say that hole should be at my C-axis 0, and it's then lined up to the X-axis direction. Auto alignment saves us a lot of time. It's a default that's on in the software, and I like it that way.
Joe, I like it that way too. I am biased, but this is one of my preferred commands inside Edgecam. So let's get back to the idea of out-of-the-box Edgecam. What all I need to do now is I want to program a part. I have a part. How do I do it?
Yeah, we've got a model, whether that came from an engineering department, if we manufacture our own parts, or from a customer, if we're a job shop, really doesn't matter. But the point is I have a model, and I can bring it into Edgecam, and it's a graphical system, and we see that model. Now, I use drag and drop, but we could also have gone to the more traditional file open, and you'll notice we have a wide range of files, both direct loaders from many popular CAD systems, as well as data translators for Parasolid, STEP, and other common formats. And the key point is that however it came in, we're going to load it. And from here out, the workflow is very consistent, no matter where the solid came from. We begin in Edgecam where it auto-detects the part, and it says this is probably a better suited to milling than turning. If I wanted to change that, I could. We'll choose the material we're going to make that from so that we can drive speed and feed lookups. And we can see that Edgecam is already beginning to collect quite a bit of information about the part. It knows the basic size. And so here I'm going to begin to take charge and say, I want the part oriented this way. And I want to set the datum in the mid-volume of the part with Z at the top. And then from here, we'll start to drive and leverage Edgecam's knowledge of the model. So out of all the different ways to add stock, I'm going to say let's go place stock that works for this part. And I'm okay with the length and width because we have stock already prepped to that size, but I do want to change the height. So when I make the height a different value, and that value could be whatever units I prefer to work with. Here in the US region, we work in the inch system, although the rest of the world seems to disagree. But that's okay because Edgecam is dual unit capable. Notice here when I say that I want 0 additional offset on the bottom of the part, that all the remaining material is stacked to the top side. So you might notice here in the setup area that Edgecam is also reporting back on the stock size. So we're really aware of both the part and the stock. And for our machining environment, there's a couple of other things that we'll next want to do. I want to add my work holding fixtures, and we can both add in complex jigs or fixtures as well as common work holding fixtures from our database. So in this case, this represents the fixtures I have available in my manufacturing shop, and there are some invalid fixtures simply because the fixtures here cannot accept the size stock that we have. So there's a very intelligent relationship that Edgecam is already aware of and considering. So let's choose a valid work holding fixture. And in this case, I'll choose this Kurt vise that we have in our machine shop. And I see it grab on the part and open up to accept the stock size, but I want to adjust the stock seating height. And so armed with this information here where we know something about the size of the part, even though I haven't taken any measurements, we can go in and say that let's say that we want to have, for example, 1 inch of material hanging out. And I can take a look at this and say, actually, the stock seating height, I put it in the wrong area. Let's say I want it this way. I can see what the effect of that is, and I can take steps here to basically put together our virtual cam setup. It looks like 3/4 of an inch for stock stick out is the value that I want. And so after adding that in, we're ready to connect this to our CNC machine. And we'll go select from different post processors that we have, which represents the machines at our company. I'm going to go choose this machine with the rotary axis off to the side of the machine. We'll connect in with a toolkit that represents the standard tools in the machine, and then just some simple directions about how to put the part together. We're going to put the part on the center of the table, and with those quick instructions, we can see confirmation about where the part lands on the machine table. And in this case here, it's a little bit close to my rotary unit that while we're not using for the setup, I don't want to run tools into, and we can very quickly adjust for that. And so if I say I want to move the part 6 inches down the table in the x-axis negative direction, we see the effect of that. This looks great. And at this point, we're ready to move on and begin to build toolpath.
Very interesting stuff there, Joe. It really shows how Edgecam part setup is intuitive and easy to use. Very, very intelligent things going on there, evidently. Now, I would like us to jump a little bit more on the everyday life of Edgecam. You know, what other types of intelligence can Edgecam give us when I am editing a toolpath, for example?
So we see the resulting path built. I want to hide away some of the previous tool path and just turn off its visibility so we can focus on what we have here. And I want to focus on this profiling cut where we're cutting the open pocket. Now in these commands, one of the things that's often key is to extend the tool path so it starts off the part. And we can see when we go over to the tab where that's handled that the start and end extensions have a suitable value. But I want to show what would happen if I use my own dialog mask. And now a mask is simply my preference on how this command should be used. So I'm beginning to, again, capture my proven process and reuse it. And now when I go back to the Start End tab, we'll notice something that visually looks a little bit different.
So Joe, why those modifiers are with a blue square around them?
Yeah, that's a great observation, Miguel, and that denotes a formula, and in this case, more specifically, a relationship. So if I was to, just to illustrate this real quick, if I went down to overlap and put in 3 plus 2, I've just put a simple equation, and notice there's a blue box around there, and when we move the cursor out of there, we see the result. Well, that's what we have in here, but in Start Extension, it goes much deeper than that. There's a relationship that looks up the tool diameter of the active tool, and then divides it by 2 to get the radius, and then adds some specific amount to very precisely calculate the start extension. And the end extension field is set to simply match that. So to put it into layman's terms, what we're instructing Edgecam is to say, whenever we have an open pocket cut, my preference is that the extension is somewhat larger than half the tool and the end should match. If I ever change the tool that's doing the work later, this relationship ensures that the tool path I built stays up to date with my machining intent.
Very nice.
So with just that one change of forcing my relationship into the dialog, again, I've taken the knowledge-based machining and exerted my influence on it. And the end result is that I have a secure process. And if there was an adjustment needed to the tool path, it's automatically handled. At this point, to resume just with the basics of knowledge-based machining, I'm going to go do the hole drilling and apply the tool path. We can see the results are that all of the tool path we built here is done, and I'm just going to leave that as is. The reality is that for many customers, hole drilling does not require an engineering meeting to figure out how we're going to drill the tool path. So why does your CAM software take that long to build the tool path? And here I see in the end results, it does exactly what I want to. We want you to get to a point where you trust that the knowledge-based machining builds a proven process that you trust. And our other colleagues are going to speak to some of the components that drive that and make that work. The program is now complete, and at this point we can go generate code, and as well as generating code, the information from the CAM system can be collected back to the database so that we can drive a live job report and an actual setup report of the tools used. Again, we see the code and even things like can cycles for our drilled cycles accurately coded out. We expect this code to be edit-free, ready to send to your CNC machine and go run and set up and operate. So just in a nutshell, that's a quick overview of the CAM process in Edgecam, both from the perspective of driving the tool path ourselves and also from the perspective of leveraging knowledge-based machining.
Fantastic stuff, Joe. Really exciting. And like we discussed before, you don't need to be an expert. You can start from a very early stage. You can start to customize the software and make it start to work in your direction with your know-how and the way you want to do machining.
Absolutely, Miguel. And I'm going to try not to take your comment about you don't have to be an expert personally, but yeah, if I can do this, you can do this.
Great stuff, Joe, and thank you so much for participating with us today. Stay tuned. Okay, so after everything we saw on what can be done with Edgecam coming out of the box, let's talk a little bit more about how can I configure the information that is fed to Edgecam via the CAM database. To discuss the CAM database of Edgecam, we are bringing our German colleague, Patrick Leuthner. Hello, Patrick.
Hi.
Thanks for joining us. Thank you for being here. So let's discuss a little bit, Patrick. What is the Edgecam 2 store, basically? Yes. How does Edgecam work with the database?
Edgecam got in the background a big SQL database where the different data come together and work together. There are 4 main applications you can use to feed this database. So you got the tool store, you got the fixture database, you got a stock manager and a job manager. So in the tool store you can save or edit different type of tools like milling tools, turning tools, probe tools, and there you can add the geometries of the tools, or you can configure it, the cutting values, the type of tools. So everything your post-processor or your programmer need to have the different data from the tool for programming.
So everything is going to be on a single database, on a single SQL database.
Yeah, it's all saved in a single database, and there are also some there's also the location for the different 3D data. They are also gonna be saved. So you have one location where all your data are saved and managed.
And I guess that's very important if you're talking a corporate level, an enterprise level. You don't want to have to do the same tools more than one time. You want to do it once, and that tool is now available to all your CAM users.
Yeah, it's not only about users. It's only about it's also about different divisions or locations. So you can have the company seated in Hamburg, and the programmer also got the data in Munich or on the other side of the world.
All right.
So they
Yes.
can share them via the company network. And also you can do some external planning or feeding of the database. You don't have to be in Edgecam to feed your databases or to manage your tools. You can when the databases are feed, you can combine them with the job manager or with the toolkit assistant. You can say you got some kind of work group or family of tools for one machine or for one product line, where you have some specific tools you only use there, or you want to reserve it for this machine. And the whole programmers, when they start programming the part and switch to this work plan, they see exactly, okay, I got on the machine this tools, or for this part we have these special tools, and they got them in their list. Another big benefit of the job manager and the toolkit assistant is that you can have the same tool in different situations or in different machines, like milling machines and turning machines. So you with a different cage and reach and different holders, but it's only one tool in the database. So if your supplier changes or if your material changes, you can change it on one place in the database. You just adjust the cutting values or the geometry, and you have reworked many tools on different machines.
Wow, that's a very, very important detail, Patrick, because you don't have duplication of data. You don't have, thousands of tools which are just a picture of the same tool, isn't it? You have different mountings for the same tool, and so you only need to change it once.
Yeah, the same with your technology assistant. You can learn Edgecam your cutting values. You can feed it with the starting cutting values from your suppliers. With the time you learn and how you can cut your material, you can fine tune and adjust it in the technology assistant, which feeds the values into the database, and the tools get these values, recalculate their feeds and speeds, and also the depth cuts, and you can recalculate the program, and you get faster and faster over the time.
Wow, and like I say, this is super, super important. The fact that the elegance of only having to change it once, you can apply the same technology, regardless if the tool has 2 flutes or 4 flutes, or if the tool is a 20 millimeter or 24 millimeter. That's all calculated automatically by Edgecam.
Yeah, that's the cool thing when the whole applications works together in one big database. So you don't have to start your calculator and do the maths by your own. You have a software for this. In the same database, we also store the stock data and the fixture data. And you got for the stock and for the fixtures some application, so the stock manager and the fixture manager, where you can save your stocks, you can adjust your stocks or your fixtures, you can use parametric models, you can use solids. When you start to program a new part and you take a stock from the database, Edgecam automatically filters and search for a stock which is big enough or small enough to manufacture your part. So if stock is too small, Edgecam says, no, you cannot manufacture your part from this stock.
Nice.
And the same happens with the fixtures. So if you have a small part, Edgecam says, okay, this fixture is okay, is ready for your part. If your part is too big, it also says, no, you cannot clamp this part with this fixture.
Fantastic. And I guess on the stock side, if there is a material attributed to that stock, that is automatically the material that will be filtered to bring in technology, cutting technology into the application.
Yeah.
So finally, Patrick, I think we talked about the, every contact point that the database has with Edgecam, and most importantly, with the automation that you can bring into Edgecam. I guess the final point is how this connects with the strategy manager, which we're going to be talking about later with our colleague David Curra, and the fact that every automation that selects a tool is going to be benefiting from this populated database.
Yeah, they are like the foundation for the programming.
Fantastic stuff. And thank you very much for this foundation, for the explanations today, Patrick. This really shows more in depth how everything you're going to see later is possible. Yeah. So thank you for the presence today, and see you soon.
Yeah, see you soon. Have a nice day.
Thank you. Take care. Right. Everything we saw until now shows you how Edgecam out of the box can help you simplify your life as a CAM programmer. But if you really want to go that extra nudge, if you really want to try and make the software follow your rules and your guides, okay? I myself always wanted and always liked to play with Excel, for example. You have macro record and playback. You can record something that you do. You go into a little VBA, change some text, put some variables, and then you play it back, okay? Edgecam offers you the same functionality, okay? So you can do scripting in Edgecam through JavaScript, and you can record any command that's going to be written down on a script, and you can edit it later. To talk about that technology, I'm inviting our big friend and my colleague, Mike O'Neill. Hello, Mike.
Hi, Miguel, and hello, everybody out there.
Good stuff. So good to have you here with us. So let's talk about Edgecam PCIs. Yes, PCI is the language, that is the API offered by Edgecam to so you can work with scripting, isn't it?
That's correct, yeah. This is available to every Edgecam user who's got maintenance license. So here we see a very typical application. We're created a number of CAM instructions. I'm just going to concentrate on the roughing and the profiling cycle. These are my best practice. These are my best decisions for making this particular set of commands. So if this is my best practice, these 8, 9, 10 CAM instructions, I want to regurgitate them time and time again. So I've just gone and captured them into a template. So we're just going to save this file to anywhere we wish to save it. It can actually be put onto an icon later on. But this file is now captured. We just put some data in here, just some information. When we rerun this particular script, it will give us some information into the feedback window. And we're going to do also combine picks, which just alleviates a lot of the physical picking on the command.
So in this case, Mike, combine picking, you are roughing and profiling the same geometry. By combining, it means that the resulting application is going to only ask once for both cycles, isn't it?
Yeah, that's correct. We just want to, less is more. I don't want to be asked twice to pick the same pocket. Just pick it once.
Good.
So now it's coming back to me and saying, well, which of these commands you want to see again? And I'm only interested in the 2 CAM instructions, roughing and profiling. So I've just highlighted them too. So we'll throw that file away and we'll open up a new one. Completely different file, but it's still a pocket. It's still being feature found using the feature finder. It's a solid. We see the 3 features in this case. I'll just concentrate on 2 of them. For time's sake, and we're going to rerun the macro. So there's the macro menu, there's the macro I've just created, and it's been now ran, and I'm just picking those 2 features, and you can see the CAM instructions now being rerun. I might want to change some of those decisions here, so that's what I'm doing, maybe on this a different material. And then there's the profiling cycle again, maybe change from climb to conventional. And now we've executed it. So within the space of a couple of seconds, we've produced best CAM practice, those 10 CAM instructions.
That was very straightforward. Basically, you copy pasted almost a toolpath from one part to a very different part, but all the same parameters have been applied.
Yeah, that's correct. It's the speed at which we apply it, and also we know that all them CAM instructions are sound. Also, we can record our keystrokes. So what we're seeing here is the command save is now going on. So every keystroke I now do inside Edgecam is now committed to script. I can even ask a question during the script. Little simple ask box. What is the speed? What is the feed? Any data, and create a variable. And remember, command save is now on, so it's capturing this piece of information as well. Save that away. So those CAM instructions that I've created, plus the creating of an ask box, have now been saved, and I can rerun them again. So let's get rid of the original CAM instructions, and now I'm going to run the macro. So now we're just going to browse the macro. We called it number 2 in this particular case, ran it, and now you'll see it's now replayed those CAM instructions again. And there they are, sat inside the CAM browser. So we just delete them off again. So what we'd like to do now is actually have a look at the script. So this is what it's been recorded. And when you first look at it, it's a bit confusing, but you can begin to break it down. And any Edgecam user would straight away recognize a lot of the vocabulary inside the script. So there we see the profiling cycle, there we see the milling cutter. So straight away they begin to make a connection between the script that's been recorded for them without really any training. All the data, straight away they can make that connection.
That's a great point, Mike, because it is striking how you end up recognizing the same names, the same values that you see in Edgecam, you see here inside the script.
Yeah, that's correct. Yeah, and obviously our programmers are very logically minded anyway, so they make that connection very, very quickly. But backed up by that, of course, is Edgecam's help file. So here we have a massive library of help and information and tutorials telling people how to create the ask boxes, what the variables are, what the directives are, and there's an ask box actually being recorded there. So there's plenty of online help for a user if they're very interested in getting into scripting inside Edgecam.
That is indeed very useful to be able to have that reference and go back and see whatever you want to change manually, and kind of if you are in that drive of creating some scripts, you don't mind the auto teaching, the auto educating around it, isn't it?
That's correct. That's absolutely correct. And now what we're going to do here is now actually turn on a PCI variable window, and this is really useful as we debug our macros, clear away all them variables. I can now open that file, don't have to go back to the big menu, and run that second macro and just run it through here. There's that question being asked to me again. I'm just going to type some information in here, a number. Obviously that number is going to get recorded. We can quickly see what's been recorded because there we go, there we can see the variable number. We'll just do that again, put another number in, refresh, and the number changes again. So within seconds we straight away begin to make a connection between ask a question. Now I can see that the fruit of my labor, it's inside the variable window. What we probably want to do next is begin to transplant that data inside our script. So there's the ask box, speed RPM, it's been supplied to SPD. Little bit of knowledge, if you put _int int in front of the variable, save it again, rerun it again, notice now what the dialog box looks like. Looks very, very slightly different now. So now you'll get the up, down arrows. It's an integer. It can only be a whole number that's being supplied, which of course speed would be. You wouldn't have 0.27 for a speed rate. And now we can see again the fruits of the labor are now inside the variable PCI.
Oh, I see. I see that when you put the integer prefix on the variable, it immediately changed the modifier type. You now you have the arrows up and down, and you can only type in an integer.
That's correct. You're almost leading the witness in a way, and you can do many other little tricks like that: radio button and string, and many others.
Nice.
So moving on a little bit, now we've gained a little bit of confidence. Well, let's try and put some more questions in here. So let's have the feed rate. So it will ask me what is the feed rate, feed weight, and then of course I need to supply a variable to that. So again, we just do the comma, and we'll just have in this case FED, not DED, FED. So now it'll make my ask box slightly larger now. So we're going to save that, and then we're just going to rerun this, and you'll see a very slight change inside the script. There we go. There's the two questions being now posed inside the dialog box. What's the feed and what's the speed? And obviously speed is now the integer. If I refresh the window, you'll now see those values coming back into the PCI variable window. So I'm making that connection from the script to Edgecam. What would be good now is that obviously our feed move command isn't using those variables. They're just some dumb numbers that are going in there. So it'd be good now to get the variables into my full script. So let's just clear off the cam instructions, and now I can see them numbers. So 2600, whatever the feed rate was originally, I just replace with the variable from my script, which in this case is FED. Just put the square bracket around there, and then the speed rate, getting rid of the raw number, and we put the integer speed in there, int speed. So now we'll see quite a big difference. We've just transplanted a question into our script. Save it away. There's the two questions being asked. And if we now look at our dialog, there we go, and you can see how they're in blue. So it's actually saying, yeah, these are the numbers that you gave me, and now actually got to use them numbers within the script. And that's something that I think Joe was showing earlier on.
Yes,
well, we've got that blue, and that's, again, we can actually create variables on the fly now. So just within a couple of minutes, straight away, we've gone and done some quite complex work. And of course, you know, this is only the tip of the iceberg. We can move on and start doing lots more scripting. Here's one I did previously. If we just run another quick ask box, we can lead the witness a little bit more. So this is what we did have, and it's as simple as that, an ask box. But you can style your ask box in a certain way, and this is one that I did earlier, where there we go, where, you know, I've got a radio button in there, I've got an integer. I call it leading the witness. So in other words, you know, there can only be 4 possible answers to that question. So it's quite clever the way that Edgecam allows us to do that. Once I've answered the questions there on my feedback window, you can see it being displayed to us. And also, if I just refresh the variable window, we'll see more variables being presented. So all them variables can be transplanted into a script later on.
Fantastic stuff. Exactly like you say, Mike, this is just the tip of the iceberg. It's you know, once you start to gauge into this universe, you really get hooked, and you can do fantastic things, isn't it?
Can, yeah, no, absolutely. This is just a very small part of it.
Good. So for those that really want to do a more corporate-like approach to standardization of best practices, we do offer one level above in terms of user experience, yeah, and that is a strategy manager. So for that, I would like to again thank Mike for being here. Thank you very much for your participation, and I'm going to be talking now to our colleague David Curra.
Be my pleasure. Thank you, Miguel.
Thanks, Mike. Okay, so after seeing all these great things you can do via scripting with Myconio, let's talk about the next stage. You know, as we mentioned, Strategy Manager is going to be the application that is going to allow us to do this in a much more clever way. To talk about Strategy Manager, I have my colleague David Curra. Hello, David.
Hello, Miguel.
Thanks for being here, my friend. This is much appreciated. So let's talk about a Strategy Manager. Let me start with a very basic. What is Strategy Manager?
Strategy Manager is a little bit different to what you've just seen with Mike. It's more about making decisions for you based on defined information that you've given it from Edgecam.
I understand. So that means you are now actually be able to visually make those decisions and implement those decisions in the software.
Yeah, that's correct. We'll take a proven process from Edgecam, and as you can see in the video there, we're transferring that information into Strategy Manager, and then we can build a strategy in the form of a flowchart, which makes it very visual and very easy to understand for a machinist. So what you can see at the moment, we're taking a proven toolpath, proven data from Edgecam, a roughing cycle, a tool change, and importing it into Strategy Manager.
So basically you can decide to do it per instruction, or you could create a group of instructions as well and export that as a process.
Yeah, that's correct. You could take a roughing and finishing cycles, if you like, and just input it into Strategy Manager as a single process. In this example, we're doing it individually, just for ease of, so visually you can see what we're doing. So we start in Strategy Manager with a start node, and then finish with an end node, and in between the two we can put any number of processes or decision making options.
Interesting. So we're going to now create a visual workflow of how we are actually deciding. We are basically transferring our know-how from the experienced user into the application.
Yeah, that's correct. As you can see, we've got the process now is we start, we call in the tool, we do some roughing, and then we move back to the tool change and then finish, so end. And we can then apply this strategy to any feature that you like, really. And in this case, we've got some pockets, so we're just going to apply it to the pockets, but it doesn't have to be that specific feature as well. We can apply this to any number of different features as well, you know.
And I just saw you saving there this strategy, this basic initial strategy on a theme. So it's basically, it is associated to the theme of Edgecam. If you change the theme, you can actually change the set of strategies that Edgecam is looking at before applying.
Yeah, the strategies are all linked to a theme. So again, you can have a number of different themes for different types of work as well, you know, or different users have different methods, you know. So yes, it's all very flexible and basically setting a default path to the strategies.
Yeah, I totally agree. Very, very flexible, because I could, for example, have a theme for cavities and a theme for multi-hole counterplates, and I can have a theme for electrodes, for example.
Yeah, exactly. So in this example, we've done a very simple roughing operation. We've created the base strategy, let's say. So now we're going to add a decision to it. We're going to take some information from the feature of that pocket and make a decision based on that feature. So as you can see in the video, we're defining a specific tool. So we're telling it when you call a tool, you're going to call in a specific tool. And what we'll do with the pockets feature is take some information from that feature, and in this case we're going to use the minimum gap. So we can then base a decision on the minimum gap in that pocket. So if the gap gets bigger or is smaller, we can change the size of the tool based on that gap. So we're back in Edgecam here, and this is the feature attributes. So it's important to understand all the attributes that are captured within a feature. Could be the depth of the pocket, could be the radiuses of the pocket, and decisions can be made on any of these attributes. You know, the flute length of the tool can be defined on the depth of the pocket and things like this. But we're going to use the minimum gap, as you can see highlighted here.
That is amazing. This is exactly where the intelligence from the CAD model is being transferred to the CAM process. This is how we read the model. We understand the attributes of the feature we're trying to machine, and those attributes are used to make decisions for the manufacturing process.
Yes, yeah, exactly. So we're going to make a decision based on that minimum gap. And if the gap is less than 20 millimeters, we're going to use a 12 millimeter tool. If it's a larger gap, we can use a larger tool. So we're going to tell it to use a 16 millimeter in this case. But that is being specific on size of tools. We could use formula in there as well, you know, so a percentage of the gap or various different formulas to define the type of tool to be used. It's also important to add to the start node what type of feature we want to use this strategy on. So in this case, I'm telling it to use it on blind pockets, if you like. Yeah. So that strategy will only be applied to a specific type of feature. You know, you don't want it applied to everything, you know. So and then once we've got that, we can use the machine feature option in Edgecam to automatically apply that strategy. So we simply machine feature, pick the strategy, and all the decisions are made for me. It makes that decision on the tool, and it goes and applies the tool path itself.
So what you're saying there, David, is that when you said apply strategy and selected the feature, Edgecam went on the list of strategies you have on the folder and found those who are filtered and prepared to machine those types of features. Is that right?
Yes, that's correct. You can have multiple strategies in that folder. You know, you can have a strategy for drilling holes. You can have a strategy for roughing pockets. You can have a strategy for machining flat faces. And because we've told it in the start node of the strategy, it will only filter down and use the relevant strategy for that particular feature. And in this case, you can see that we had different pockets on different angles. So we're going to add an index command. And it's so simple. We just take that index command from Edgecam. We output the process, load it into Strategy Manager, tell it how we want to pick the index move. And in this case, we're going to take the work plane that's being created automatically on that feature. We then insert the index move into the flowchart and simply redirect some of the moves from one command to the next. So after we pick the tool, we're going to index and then move on to the roughing.
Nice. That is, it doesn't get simpler than that, does it?
No, of course. It's this is a very basic example, obviously, Miguel. We can make this as complicated as you like, you know, but for most applications, you know, we just like a simple solution, you know.
Great.
So moving on here, we've got a different strategy, and this one a little bit more complex, but you know, nothing too difficult really. We've got 3 decision nodes at the top there. We can color code these nodes just for ease and visual purposes really. But it's making it's got 3 decision nodes in there, so it's deciding what type of hole it is. Is it a counterbore hole, a blind hole, a through hole? And I've got a different method of creating each hole depending on the type. So again, we can just go in and apply this automatically inside Edgecam once it's all set up.
Wow. Fascinating.
Yeah, so as you can see, all of the commands have been populated in the sequence list. And after that, we can always use the rationalization and optimization of standard Edgecam to reorder and optimize the toolpaths accordingly. So to take this to the next level, we can use the planning board. So this is the way Edgecam defines how it wants to machine that part for you. What have I done initially is applied the shipped strategies. So we've got a list of strategies there. It's going to rough and finish and index automatically within these strategies. But I want to apply my own strategies, not the shipped ones. So that's just a simple case of going into the settings and redirecting the paths. And we do this through the themes. So just set the themes to whatever the new one is that we've just created. And then if we use the planning board, it knows, you know, we're going to use the strategies that I've just created. So when we hit a plan this time, you'll see we get a different list of strategies.
Oh, I see. So the shipped strategies are the same we saw at the beginning of the webinar with Joe Sanders. Those are the strategies we saw when he ran the planning board. We are now using your planning board, the one you just created.
Yeah, Yeah, exactly. That's correct. So, the ship strategies are great. They'll do 90% of what you want. But if you wanted to set them specifically to your requirements, you might have a different way of machining pockets, different tooling, etc. So, yeah, just set the path. And now I'm applying my own strategies here. They're all coming in green there, so I could have color coded them as well. So you've got different colors for roughing and finishing and drilling. So it just makes it, again, just visual really, but does help.
And this is fantastic, David, because it shows that yes, okay, you can use our strategies, and like you say, they are shipped and they are an example of how to do things. But of course, you have your own know-how and your own expertise on how to machine your type of parts with your preferred tools, and you can basically configure Edgecam to contain all of that knowledge inside the application through decisions and through the processes that you want to do. And those are not static. They can be evolving every single day with new decisions and with new methods and criteria for that machining process.
Yes, that's exactly it, Miguel. That's the whole beauty of it, is you're capturing the information that you've already defined and already used, probably. Prove that the methods are correct, and then automatically apply them with simple 2 clicks, plan and apply. It couldn't get much easier.
It could not get any easier, David. Thank you very, very much for participating on this today, and I wish you a great day.
Thanks, Miguel.
Okay, so that was very, very exciting technology around Strategy Manager. Now, as you saw, there are some attributes that come from the machine. And Edgecam is a product that is highly reliant on the machine that you are trying to program. Edgecam is aware of that machine, and Edgecam is trying to program for that machine. To talk about the machine configuration and the application that we call Code Wizard, I have our colleague Ralph Goppelt with us. Hello, Ralph.
Hello, Miguel. How are you?
I'm good, thank you. How about yourself?
I'm fine.
Yeah, good stuff. Thank you for joining us today. It's a pleasure to have you with us. So we will be talking about Code Wizard. Yes. What exactly is Code Wizard?
Code Wizard is a great tool to create a virtual machine of the real, let's say, a copy of the real machine, which translates the instructions we get from Edgecam for the toolpath and for the movement of the axis, to show it in the simulator so that we have a real verification of what we are doing.
Oh, nice. So literally, Code Wizard is the tool to configure your virtual machine, is it?
Yes, it's split into 2 parts. The main part is the configuration of the machine model, of the machine kinematics, how the axes belong to each other, how the machine looks like. We have the option, if we have no real model, to make a parametric model of the machine, which we can adapt in various ways to fit to the real machine. And we have several configuration options to make it like the real machine.
That's very interesting, because you can if you don't have the machine graphics, you can actually create a kind of a parametric model of that machine as well.
Yes, by a few clicks you say, I have these and these axes, they belong in that way together, and create me a virtual parametric model, and then with the click of a button I have a starting model with which I can work.
Very, very nice. And I guess if you do have a solid model, like we see in the video, you can actually import that inside Edgecam or Designer, and you can use that solid model to represent your machine directly also inside Code Wizard.
Yes, of course. That makes it even more interesting to have a real model. Normally you have to make some adjustments to the model to have it more easier, and then you can copy it over to the Code Wizard and place the parts of the model which belong to the axis into the right place, adjust the axis and the moving values. Yeah, and so you get closer and closer to the real world.
Fantastic. So in the end, you end up with the exact representation of the kinematics of your machine. You can move all the axes and move all the parts like you do in real life.
That is true.
Good stuff. And I can see on the video that, for example, you are selecting that some elements can be flagged as collision detection and some are irrelevant for the collision detection, like the doors or the housing of the machine.
Yeah, you configure which parts are important for collision detection. You can group the parts so that you have the easy way to switch them on and off in the display.
That sounds easy enough and sounds like doable by any user or application engineer. So after you've done the kinematic, we need to talk about the NC code. So we need to now configure how we output instructions for that machine.
Yes, in the first part we have to tell Edgecam some information about the machine, and that is the configuration of the machine, where we tell Edgecam what the machine really can do. And finally we come to the Vnc output, which is the main task we are looking at, and there we can configure each part of the Vnc output for linear moves, for circular moves, for tool change, for the tool list or the program head, and so on. It's easily made in code constructors and with selectable tokens which can be placed in the output. The tokens itself, they can be formatted through the format table, where I determine which is the correct way to output a value with dot or comma, with how many digits, and so on. You tell the code wizard what is the M codes, the G codes. Yeah, you can nearly configure everything.
Fantastic. And I think the very important detail here is that you're not only configuring a post processor, but you are configuring the environment of Edgecam. Once you have selected that machine that you want to create a CAM project for this machine, the environment is going to show you the commands available for that machine, and Edgecam is going to behave as if being programmed for that machine. So it's not only post-processing, but attributes of the machine that actually influence the act of programming.
Yes, it's a two-way communication. Not only the CAM tells the post processor or the virtual machine what it has to output, the virtual machine tells the CAM system what the machine is capable of. Not only the kinematics, but also stuff as axis limitations and how is a 5-axis simultaneous created, and yeah, many things to configure.
So you are so much in the environment of that machine that you can actually create commands that are unique to that machine. What we call them M functions or machine functions, isn't it?
We have several possibilities to add machine-specific stuff to the virtual machine we are creating. The most simple way is to add an M function which only does some action on the machine and does not influence the toolpath or something like that. So we only say, yes, output a special M code to perform the action you want to do. Let's say to open the automatic door or something like that.
And that command will actually be visible inside Edgecam.
Yes, you have the drop-down menu for your M functions where you can select it as you created it.
Perfect. That's really, really good. Ralph, this was fantastic technology. Thank you very much for participating on our webinar today, and speak to you soon.
It was a pleasure. Thank you.
Now we're going to have a look at a real-life case study coming from Italy. For that, I have my colleague and dear friend, Pierandrea Capelletto. Hello, Pierandrea.
Hello, Miguel. Hello to everybody.
Thanks for being here. What can you show us on the problem solving that this customer was facing, complicated machine kinematics, and how it was solved using Edgecam automation?
Yes, we have a real case of our customer that have a complex machine, because this machine is a 3-axis but have a different head vertical, head 5-axis or orthogonal. fixed with an angle, and want to have in one sequence, like in this case, and one ISO code, one post-processor, and one CAM system. Now we show that we have make a special teams for the complex machine, that we have not only the standard HM cycle, but we have a special cycle that can move and load different accessories like an head. First, we started with the standard Edgecam milling cutter, no difference. Choose the quill position because we need to understand where is the second Z-axis from the main, and put manually a value like minus 1000, or fix the position like the first, the second, the third. In example, this is a new command made by a PCI JavaScript using a mask, use XML, and use in this case a Navi file for make the correct simulation, for make a quickly environment to use for the basic user of Edgecam starting 2 days of training. For first, we put the first movement and choose the head. The same like the quills position, we have a complete command with the bore, with the fix, with the 5-axis head, and we put in alternative solution or not, we choose the plane or manual insert of C angle or B angle.
So you can really customize the dialog to the need of your customer. You can make the AVIs or GIFs and images, and all the settings actually follow that on the mask.
Exactly. In this case, we can choose for first the bore head, go to Edgecam parts and make a simple profiling of the open pocket. Choose the standard command, tooling, load current tool, and use the potentially of Edgecam solid, like the associativity of a level and depth. Click OK and make the first cycle. Okay. For make the second, like in left side, we make a new tool change for have the real simulation of the machine. Load another tool like face milling, 50 millimeters. Choose another type of head, in this case 5-axis, and left plane. Put OK. Quill position, we use a fixed position, but in the position 4. Now we can finish the job with the simulation. First quills, second, and close.
Wow, this is really interesting, Pierandrea. So, and this case is, like you said, is a interchangeable head situation. I think we have also a scenario with the Trevisan machine, isn't it?
Yes, because the problem is the same. Have a simply and customized CAM system for make quickly the parts. We have the second, is a valves from oil and gas, and we have started to customize Edgecam not from only the machining areas, but from the geometry areas, because sometimes we need to make two types of work plane. The first for milling and the second for turning. Manually, you need to use a work plane like an Edgecam command, but we have a special macro, special command composed from PCI and JavaScript, from AVI file and mask, where we can put the name of the datum, one in example. We can choose if you need to create the relative turning work plane or only the turning work plane, and eventually you can make a shift from the Z of a turning work plane relation to milling work plane.
Really interesting. This entire dialog was created just by JavaScript and is focusing on the needs of this customer with this piece of technology, isn't it?
Exactly. Now I click OK. I click a cylinder face, click the position, and we have created the datum from milling. That one, fresa is a mill in Italian, sorry for the translation.
Portuguese as well, yes.
Exactly, and the datum is the same from turning, automatically creation. Now we go to machining, and we have a totally different milling and turning command, because we have the tool. Tool is totally customized from Trevisan accessory, because we need to have especially tool holder for turning.
Nice, sure, yeah.
This is all solid that is developed inside a CAD system from Trevisan and put inside Edgecam, totally customized.
Right, so you can have any solid models to represent holders and fixtures and your entire machine, basically.
Exactly. Now we show you the machine. The machine is a very specific machine because it have two positions for have a different range of diameters. Have a third position that is the milling spindle, and we choose with the turning tool. Another type of customized command where we found and we chose the datum. We chose where is the position in M61 or M62.
Nice.
Eventually, description like example 1, example 2, or first turning, second turning. And is more important for Trevisan where is the open and the head rotation, because start with the off, clockwise, anti-clockwise. We can open the constant surface because it's a turning logics, and more important is the position where the M3 is put before the rapid and after the rapid. We choose it because it's more safe.
Yeah.
Click OK. Automatically Edgecam is ready to use the standard cycle. Second click. Standard cycle with the cut increment, with the option to optimize the pass about the stock position and stock dimension. Click OK. Zoom to the profile. It's a typically Edgecam turning cycle with a cut increment, stock option, with the feed rate. Click OK and choose the feature. The feature is the standard Edgecam feature made by manually selection of face or automatically feature finder. Click OK and we have the cycle for first phase. The second phase uses the index from Trevisan that choose the second datum, choice to optimize the stock or not, and we are ready to apply the second cycle in the second phase. Now we can close with the second feature, okay, and eventually go to the milling, closing the turning off with a.
What really makes it that easy and simple is all this customization around, isn't it? You are concentrating and automating a lot of the steps that are perhaps repetitive sometimes, but you configure the environment to behave and feel exactly with the commands that you need at the moment.
Exactly. The same is when you finish the turning. You want to put a comment, you put to M0 or optional, is your choice. Or click OK and choose the new tools that is not a turning but is a drilling, because you want to make the spot drill, milling on, and choose where is the plane. Datum 1 for milling or datum frame. The quill position can are the manually position, stock update, and now we are to the 3D stock and using the whole cycle. Solid, drill, we use the standard Edgecam feature, click OK and choose the feature. Go to simulation for close the job. We have the machine that is stopped, but now for first position, not around the head, rotation of the head. I make it. Second turning. Close the turning job. Open the milling job with the quills. I make the drill.
Nice. Fantastic job.
Close the milling and generate one ISO code, not 2 or 3 or other, but is only one.
There's going to be an edit-free NC code ready to go to the machine.
Exactly.
Fantastic job. I'm so happy to see this, Pierandrea. Really, really great. And like you and I discussed before, you can do that for any customer that has the need for a verticalization of his CAM system. Edgecam is there to do that for you, and he's capable of doing thanks to the entire automation environment around the product.
Yes, yes.
Good stuff. Pierandrea, grazie mille. Once again, thank you for this. It was great, and see you soon.
Thank you, Miguel.
Thank you. So much fantastic technology that we just saw on this webinar until this point. Let's wrap it up with a success story from an important corporate account in North America. To talk about this success, I have with us our colleague, Jim Jackson from America. Hi, Jim.
Good morning, Miguel, and welcome, everybody.
Yes, good. It's good to have you here with us, and thanks for being here with us. So, Jim, talk to us a little bit about John Crane.
Great. The project I'm going to be showcasing today is from a company called John Crane. John Crane is a global company with manufacturing facilities worldwide. They're headquartered in Chicago, and they're part of the Smith Group. They provide engineered solutions to the process industry. I have been personally involved with John Crane since 2002. I have seen their journey. In 2002, they moved away from their language-based CAM system called Compact 2, and they went to a more graphical CAM solution, and they selected Edgecam. So they've been working with Edgecam for the last 19 years. John Crane was like everybody else during that time frame. Everything was programmed using 2D geometry, wireframe geometry, stick geometry, whatever you want to call it. It was all manual programming. Very little automation, and where the automation was, it was always with wireframe geometry. It was about 4 or 5 years ago that John Crane started investigating and discovering the advantages of integration between CAD and CAM. They have Solid Edge as their global CAD solution and Edgecam as their global CAM system. Some of the key factors that they discovered during this investigation is that they have the attributes on the solids. They're there. Use them. We want to eventually eliminate their need for prints. We want to go paperless. Keep the design intent. Consistency. They want to be consistent in their programming, thus eliminating costs on the shop floor, whether it be direct or indirect. The John Crane vision is, how far can we take intelligent automation? They want to be on the cutting edge of technology. They want to push the boundaries. It's not just their CAD and their CAM, but they're also machine tools and their tooling. Here's some examples of the sleeve family, sleeve product line that they want to have an automation project for. If you notice that these sleeves are thin wall sleeves, they can be up to 8.5 inches in diameter and 12 inches long. Thin wall sleeves create very interesting cutting conditions. You introduce vibration, and when you have vibration, you introduce chatter. The way you remove material is so key with these thin wall sleeves. So when we sat down with them to discuss this latest project and start gathering the information, we found out that they wanted us to create a rules-based, feature-based automation project for this sleeve product line. We were to use their proven methods. It must be flexible, it must be scalable, and it must be global. When we talk about their overview and some of the notes that we take, we found out that every sleeve is custom ordered. There's no stock sleeves. They programmed last year over 1,500 distinct sleeves with 6 programmers. You do the math. Their lot sizes are just 1 to 2 pieces. Their bearing bore diameters and their tolerancing is plus 1,000s minus 0. Very, very tight. The material product mix is pretty much 85% stainless steel and 15% super alloy. So we're introducing Inconel and Castalloy, some nasty material to machine.
Yes, I can imagine.
So for their expected outcome and what they're basing their ROI on, we needed to reduce their programming time from hours to 15 minutes, decrease their on-machine cycle time by 50%. They have an acronym called NRFT, do it right the first time. And we're going to accomplish this by adding additional gauge passes, spring passes, and finishing passes. They want to put the stock in, take a finished part out. And any unsupported features, new things that engineering introduces, we needed a way to notify and message the programmer that there are situations out there and features that they had to address manually. For their expected functionality, we had to automatically select their stock. We needed to synchronize the main and sub-spindle toolpath, part transfers, everything had to be automated. OD grooving, ID grooving, face grooving, helical drilling, balance turning. And we introduced something brand new, PMI data.
So Jim, it sounds like this entire project was much more than providing CAM software. It was about understanding the entire workflow and most importantly, connecting with all the left and right parts of the flow vis-a-vis the CAD model that has intelligent information on it, had to be read inside the CAM automatically and then output and C code that is intelligent and ready for the machine.
That is correct, Miguel. We are harvesting the attributes that are associated to the feature, and this also includes PMI data. And if you're not familiar with PMI, that means product manufacturing information. We are now bringing in tolerancing. We can find out where tight tolerances are, and then we can make intelligent manufacturing decisions based off that information.
Right.
Surface finishes. We can now change our speeds and feeds automatically, no more manually. That's all part of PMI data and this project.
Jim, so you've been showing us some fantastic technology and how Edgecam can help our customers, and in this case, John Crane, be much more automated, be much more driven by the automation of our system. What is the bottom line? What is the final result that we achieved at this customer?
Good question, Miguel. In less than 5 minutes, the part is machined and G and M codes are already created. Edit-free G codes and M codes. From a success rate, how did we do? So far, we have decreased their cutting time by over 48%, programming time by over 50%. We've had dramatic quality improvement. Scrap has gone down immensely. The biggest thing is their payback on their ROI, on their case study, is 6 months. They've already paid for it. That is the bottom line. They are successful. It is a proven good project.
Ladies and gentlemen, Jim Jackson from America and the case study with John Crane. Thank you, Jim.
Thank you, Miguel.
Let me close this webinar with a little thought. There is a lot of CAM systems out there that can effectively machine a part. How efficient they are at doing so is the real question. Think about everything you saw today around Edgecam and how efficient your customers can be using all of these tools. Yeah? There is a lot of very good quality marketing happening around CAM products. Edgecam is the unique solution when you're thinking about continuous improvements on your manufacturing process. Let's open up for some questions in our live event. Let's see what people have been asking us.